This lesson is on graphing quadratics in standard form. And the approach I'd like to take with this lesson is to look back at things that we've already studied and review those concepts because math is consistent. I know I say that all the time, but it's true. Math is consistent. So what you learned about lines or how lines work in that family of functions called linear functions, and what you learn about absolute value functions transfers over into the new families of functions that we study. So when we looked at lines, one of the things that we discovered about lines is that they can take different forms. So for example, we have something called the slope-intercept form of a line. And this is often people's favorite form of a line. This is the y equals mx plus b. And we like that because it's often easy to write equations based on slope-intercept forms. So like the little word problems where, Sally has, $25 in her bank account and she adds $5 each week. Those end up being in slope-intercept form. It's also easy to graph lines from slope-intercept form because you can plot where the y-intercept is and then you can count the rise over the run for the slope. And it's just a very quick way to graph. We've also looked at linear equations in standard form. And standard form is this form where you have like a number, let me be consistent with my colors here, where you have a number times x plus a number times y equals some kind of number. And we would see that in word problems that sound like it costs, $5 for an adult ticket and $3 for a child ticket. And altogether it comes to like $15 or whatever. And so that would be your standard form. And you can go from standard form into slope-intercept form. So if I gave you an equation like 2x plus 4y equals, I don't know, what do I want to do here? Equals, this is going to come out bad no matter how I do it, but equals 7, okay? And then you can subtract the 2x from both sides. And you get 4y equals negative 2x plus 7, and then you would divide everything by 4, and you get y equals negative 1/2. What I did there was I simplified 2/4 into 1/2, and then this is lovely. Yeah, that's just how it comes out. But you can take something that's in standard form, ax plus by equals c, and you can rewrite it in y equals mx plus b form. You might not like the numbers, but you can go back and forth between the different forms. There's actually more forms for an equation for a line. There's something called point slope form, which several of you were using at one point. I don't always cover it in Algebra 2 because I can teach you how to do everything you need to do with the lines by just using the two forms. So I tend to try not to put other stuff in there. Now, just like lines come in more than one form that have different advantages to them, quadratics also come in more than one form. And remember, quadratics, just a quick little recap of quadratics. Your tip-off that something is a quadratic is that it has an x squared in it. And we did a lesson where we looked at what's called vertex form of a quadratic. So vertex form for a quadratic is this. It's the a, and then we have x minus h all squared plus k. And that's the official form. Now, when I teach it, I often put the negative out in front when I'm explaining the transformations, because if this number out front is negative, then you'll have the flip in the shape of the graph. And then you have this, which moves it left or right. If you have minus a number, it goes to the right, plus a number, it goes to the left. This right here, the squaring, tells you that it is a quadratic. That's your x squared. And then the number being added or subtracted on the outside. And notice I say outside and I don't say at the end, because there are some families where you'd see that added or subtracted at the beginning. But it just means it's outside the squaring. That's your up and your down. And so in the last class, we practiced graphing by identifying like the left and the right and up and down and the flip, and we were able to sketch them. Well, today we're going to look at something called the standard form of a quadratic. And the standard form of a quadratic looks like this. y equals ax squared plus bx plus c. And that probably looks familiar to you. There's a lot of stuff that you guys cover in Algebra 1 that I don't think you should touch in Algebra 1, but this is one of the things that you probably should have seen. When you look at this, notice that there's a connection between the standard form of a line and standard form of a parabola, meaning that you have like the a and the b like are the coefficients, are these numbers. And when we get to higher order polynomials, these are actually both polynomials, but we're not really using that word yet. But they are. You letter your coefficients starting with A, B, and then C, D, E, like and so forth. Okay, so what we're going to do today is look at how do I graph from this standard form. So as usual, and I'll put the question here. Here's the question. How can we sketch a graph from standard form? So that is our standard form. That's our key question. By the end of this lesson, you should be able to answer that question. So I'm going to do what I usually do and set up like an example problem with some steps, and then go through the steps and then run an example at the same time. I'm also going to try to color code it like I usually do so that you can see like this is what the step is and this is what it looks like when you carry the step out. I'm going to do one example very, very slowly, and then I will do the next examples more quickly. So the example that we're going to start out with is f of x equals x squared minus 6x plus 5. So take a moment and write that down, x squared minus 6x plus 5. Now, if you don't like having the f of x, you always have the, I didn't quite change the tool there. You always have the option of using a y. Okay, you can always take an f of x and replace the f of x with a y. What you can't do is always take a y and replace it with an f of x. It doesn't work the other way around. But if you ever see an f of x and you don't like the f of x, you're welcome to replace it with a y. That's never going to cause you to get anything wrong. Now, before I do anything else, I am going to identify A, B, and C. And I do want you to take time to think through this. There's a couple of mistakes that students make. Now, what I don't want you to think is that it always goes from left to right. Now, if you're in standard form, it will, because standard form, it goes A, B, and C from left to right. But sometimes a problem might give it to you kind of jumbled up. And so take care. A is always the number in front of the x squared, even if the function is given to you with the x squared like moved over to the end or something. So just be aware of that. A is always the number in front of the x squared. In this case, the number in front of the x squared is a 1. That is 1x squared, that 1 times x squared. It's not a 0, it's not missing. And so my a value is 1. My b value is actually -6. So remember my Algebra 1 teacher, okay, who was weird. He wouldn't let me write -6. He would make me write in my algebra class plus -6x. And the reason he did that was because if you write it this way, you are more likely to remember that that is actually a -6. Now, I'm not going to require you to do that. You are welcome to write -6x as long as you remember that that means the coefficient of the x is -6. And then, of course, we have the 5 out here. Okay, so A is 1, B is -6, C is 5. You don't always have to write that out. When I'm doing problems, I don't make a list of A equals B equals C equals, but it is important that you are aware of like the little mistakes that you can make. And if you tend to make those mistakes, then you probably need to take this additional step. It doesn't take long to write it out. And if it can help you avoid a mistake, it's certainly worth it to do it. Now, the first step in graphing a parabola from standard form is to find the axis of symmetry. So AOS stands for axis of symmetry. And there is actually a formula for that you will need to know, but I'm going to give you a way to know it. That is x is equal to the opposite of b over 2a. I'm going to hold you up a second, write that down, pause the video if you need to. if you're doing this at home on your own. And I want to call your attention to the way that I said it. I did not say negative b. I did not say minus b. Now, I can say those, and it's not wrong. So if you say it that way and you've had a teacher that says it that way, that's totally fine. The way I said it, though, was the opposite of b. And the reason I do that is because of my geometry teacher. Mr. Oakes made us say the opposite of. And the reason he had us do that was because it helps to avoid a mistake with the positive negative nature of the number that you're going to put there. So if I say negative b and b is -6, there is sometimes a impulse to just write -6. But if I say the opposite of b, and I ask myself, what is the opposite of -6? Well, the opposite of -6 would be +6. And you don't have to write this like double negative. Nobody likes the double negatives, okay? But the opposite of -6 is 6. And I will consistently say that. And then I go and write it wrong. Hold up. Okay. The opposite of -6 is +6. And that goes back to maybe the first class or the second class of the year where I introduced the vocabulary word, the opposite of. So the opposite of b, the opposite of -6 is +6 over 2 times a. And then we want to be careful about our order of operations. So we're going to do 2 times 1 first, which is going to give us 2. And 6 divided by 2 is 3. So the axis of symmetry is x equals 3. Now, on your graph, your coordinate plane, you are going to graph the vertical line x equals 3. So you can't count over on your x-axis 1, 2, 3. And I am going to have you do a dashed line at x equals 3. Notice that that is not a function, okay? Like x equals 3, the vertical line is not a function. It doesn't pass the vertical line test. And we're going to do a dashed line. Now, the reason that I'm making it dashed is because this is not actually part of the parabola. It's a useful thing for us to put on our coordinate plane, but it is not actually part of the parabola itself. And so I'm going to dash it. So we go over to x equals 3, 1, 2, 3 on the x-axis and do a dashed line. If you need to pause the video for a moment so that you can put that on there, go ahead. In fact, I'll like label it on this grid here. That's my axis of symmetry. Step 2 is to find the vertex. Because remember, that's one of our key points. Okay, so here's the deal. The axis of symmetry, if you recall from the last lesson, and if you have tried to take some shortcuts, and I know I wasn't in last week, so you were trusted to go and watch those videos on your own. If you did not watch them, go back and watch them. And please do not tell me that the videos don't help you if you're not watching them. So please go back, like if you're doing this from home, okay, stop this video right now, go back and watch the last one, and then come back and resume this one. If we're doing this in class, then I want you to put on your list of homework assignments for tonight that you're going to watch that video, okay? Because we can't move on to step 2 if you haven't done step 1. The vertex of the parabola is somewhere on the axis of symmetry. And I don't know if you kind of follow how I'm tracing here. I don't know if the parabola looks like this or like this. I don't know if it's like really wide or if it's super skinny, or maybe it goes this way, all these different ways that I'm tracing the parabola. But what I do know is that the vertex is somewhere on that line. And so the x coordinate of the vertex is 3. I'm going to repeat it. The x coordinate of the vertex is 3. Okay, now let's go think about this. If I know that the x coordinate of the vertex is 3, then to get the y coordinate, I would take the 3 and I would plug it in for x, and I would figure out what y value goes with it. I am going to repeat it because I know sometimes it's easy to tune out, or like I'm monotonous, and I totally get that. I think my own videos are boring sometimes, but it's important. So it's important that you give your brain time to digest it. If I know that the x coordinate of the vertex is 3, then I can take the 3, plug it into my equation, and I can get the y coordinate, and that will give me the vertex. So that's going to look like this. Now I am going to put that 3 in parentheses. No, it is not necessary, algebraically speaking, but if my x value is negative, then it will be necessary. And so I would urge you to always put it in parentheses, and then you don't have to think about whether or not you need the parentheses. If you have a calculator that will do like the chained operations, you are welcome at this point to just go through and dump that whole thing into your calculator and get an answer out. I don't have a calculator on this program that I can demonstrate with, so I will go through the order of operations. 3 squared is 9. Make sure you're not writing 6. Okay, 3 squared means 3 times 3, and 3 times 3 is 9. It is not 3 times 2. Minus 18 plus 5. Please, please, please note your order of operations. Addition and subtraction go from left to right. So you are not going to do the adding first. I know that in PEMDAS, the A comes before the S, but if you listen to the instruction, it's from left to right. They actually have the same rank. And so this will be 9 minus 18 is negative 9, and negative 9 plus 5 is negative 4. And so the vertex is the point 3, negative 4. And now I'll come over to my graph, and I'm going to plot 3 and then down 1, 2, 3, 4. And I'm clearly going to put my vertex right there. All right, let's move on to the next step, which is to find the y-intercept, and I'm just debating how I want to do this with the ink. Okay, I did a duplicate on the page with all the ink, and then I erased the part of it that I didn't want for right now. But it's still there. It's like over there. And I can click back and forth. Okay, step 3 is going to be to find the y-intercept. So let's go through the reasoning. I do not want my students just carrying out steps like little robots. You guys are not little robots, okay? And so when you're reading through the steps, I want these steps to make sense. I think that a lot of you have gotten to the point where you automatically go to the internet and you just start looking up the answers to the problems because you've given up with it trying to like make sense to you, but like that's not a lost cause. So put the internet down and follow the thought process here. The y-intercept is defined as the point where the graph crosses the y-axis. I'm actually going to put that definition back up here, okay? Y-intercept is the point where the graph, and I feel like I misspoke like a second ago, and I can't rewind it to check it, crosses the y-axis. That's the definition. So I have a parabola. Somewhere that parabola crosses my y-axis. Take a look at all the points on the y-axis. Okay, all these points, every single one of them. If I were to look at the x-coordinate of every single one of these points, what would the x-coordinate be of every single one of those points? Okay, and hopefully as you're thinking about it, you're thinking, oh, the x-coordinate would be 0. It might be 0, 5, or 0, 4, or 0, 0, or 0, -1, or 0, -7, but the x-coordinate of the y-intercept is always 0. And again, that's part of why Miss Braswell always makes her students list the y-intercept as the point 0 something. Like, math teachers have these like little quirky things that we'll have students do, like writing plus negative, or saying the opposite of b, or like Miss Braswell always writing the y-intercept as 0 and then a number. But there's a reason to it, and it's to help students make those connections between the vocabulary we're using and the numbers that we're putting up there and where the graph is. So if the x-coordinate of the y-intercept is always 0, then to find the x or the y-intercept, I would simply put a 0 in for the x. And of course, this will give me 0 minus 0 plus 5, and I hope you realize that that is 5, and so the y-intercept would be 0, 5. I'll pause for a second because I just wrote a whole lot on the screen very fast there. We have x is 0, so the y-intercept is 0, 5. So over here, I'm going to go up 5. 1, 2, 3, 4, 5. And put my y-intercept there. Now, there is a shortcut for this, okay? If you have an equation that's in standard form, so let's go back here to standard form, okay? And you plug in a 0 for x, what will happen to ax squared? It'll be 0, because you'll have something times 0. And then if you put a 0 in for this x, it will also be 0, because you'll have something times 0. So if you plug in a 0 for the x's, you will always be left with just c. And you can see that that's what happened in our problem right here, is we were left with the c value. So the shortcut on this, okay, is that it will always be c. But I don't want to just tell my students, oh, the y-intercept is always c, because sometimes you're going to be given a parabola in a different form, and it might not be obvious what c is, and it's more important that you understand that the y-intercept means that x is 0, and that's the reason why it's c, because the terms that have x in them are going to end up dropping out. Okay, we are actually almost done with this entire process here. So step number 4 is going to be to reflect the y-intercept over the axis of symmetry. So I'll give you a chance to write that down. Reflect the y-intercept over the axis of symmetry. So remember that the axis of symmetry is the mirror line. It goes right down the middle of the parabola. So if I have a point that is 3 units to the left, there must be a mirror point that is 3 units to the right, because this is a line of symmetry, the axis of symmetry. So that means that there is a point 3 units, the exact same distance away over on the other side. And this gives me enough that I can do a sketch of the parabola. We're not doing this super accurate graph like we do with lines, where we want every, we're going to bust out our ruler and stuff. We're just trying to create a sketch. And so the very last step is to mess this up. Okay. Draw a smooth curve as best you can. Okay, as best you can. We know that the vertex of the parabola is here, and we know that it goes through these points. And so I'm doing this on my iPad, and it that works. Okay, so what do I need to see in order to give you full credit for your sketch of your parabola? I need to see the vertex, I need to see the y-intercept, and I need to see that mirrored point. Now this, the only time this strategy really doesn't work is if the axis of symmetry is the y-axis, and that means your vertex is the y-intercept. And if that happens, you would just simply pick another point, pick x equals 1 instead of the x equals 0 that we used right here. And then you could just do the same thing where you're mirroring it. But most of the time, your parabola, like the axis of symmetry, is not the y-axis. And so this works most of the time. So that's all I'm going to do for this lesson, because this lesson went, it's like at 25 minutes, and I don't want the lessons to go longer than that. So you basically won't have any new homework. I want you to go back and rewatch the old videos if you were taking shortcuts while I was out and you weren't watching them. You have until, if you're period 6, I probably read you the riot act about the activity from Friday, so I want you guys to get that caught up, and then we'll resume with some more examples of this in the next lesson.